We talked about the chain rule. Now let's looking at some examples. So the first one we want to integrate 3x squared times x cubed minus 3 squared dx. We can see that we have an inner function, which is x cubed minus 3. So let's just let the inner function, x cubed minus 3, be the u. Then du is going to be 3x squared dx. We see that 3x squared dx, 3x squared dx, we can find the exact terms inside our original problem. So now we can just simply rewrite it as u squared du. Let's remove the parentheses. So u squared du. Now to integrate this one, which is just using the power rule, 1 over 3 times u to the 2 plus 1 du. But we do not want u, so we're going to have x cubed minus 3 to the third power over 3 plus c. And that is our answer for the first problem. Now let's try a second one. The second one, we have sine and cosine function. So this one is a little bit harder to see the inner and outer function, but we know that sine and cosine function, the derivative of one is the other. So it is easier and makes sense to set the bottom one as the u. And in fact, this one, sine squared t, this is actually sine t, the quantity squared. So we can see that the inner is going to be the sine of t. So we can let u be sine of t, and du is going to be cosine of t dx, and we have exactly cosine of t dx. So the whole problem can be rewrite as integral du over u squared, or 1 over u squared du. But I do not like writing it in the fraction form, so I'm going to rewrite it into the negative exponent. Now it is going to be a power rule, 1 over negative 3, actually negative 2 plus 1, which is negative 1, and u to the negative 2 plus 1, which is negative u to the negative 1, which is negative u is sine of t to the negative 1. But remember, this is negative 1 power. It is different than the inverse. So negative 1 over sine of t plus c. Then the last one, the last example we will talk about in this video, it is a definite integral. I want to integrate from negative 1 to 0 of y times 2y squared minus 3 to the fifth power. So it is pretty straightforward now, hopefully. The 2y squared minus 3, it is the inner function. So we can let u equal to 2y squared minus 3. Then du is going to be 4y dy, since we have variable y now. 4y dy we do not have, but we have y dy. So we can divide it both sides by 4. So y dy is going to be equal to 1/4 dy. So the whole thing is going to become u to the fifth power dy, or 1/4 dy. Let me just put the 1/4 next to dy first. Du. However, we're not done yet. Remember, we still have the 0 and negative 1. You have two methods to do it. One is you're just going to keep in mind you haven't touched the definite integral portions. You're just going to wait until the end once you finish all the integrations. then you're going to plug in your y as -1 or 0. Or you can say that I can change the definite integral from now for u. So when y equal to -1, u, which is 2y squared minus 3, will becomes 2 minus 3, which is -1. When y equal to 0, u, which is 2y squared minus 3, will become to -3. So this definite integral will change from -1 to -3. You probably feel like this is a little weird. Like is supposed to be from -1 to 0, which is a smaller number to a bigger number, but now it's changing from -1 to -3. It sounds a little bit weird, but let's just keep it in that way first. Now let's do the integration. The integration, it is going to be 1/4 to the front, u to the 5th, which is 1 over 6, u to the 6th power, and then we're going to evaluate it from -1 to -3. Which is going to be 3 to the 6th power, -3 to the 6th power over 24, minus -1 to the 6th power over 24. So 243 over 8 minus 1 over 24. So let's just keep it as 3 to the 6th power. 729 over 24, which is equal to 728 over 24. And it's still not a whole number. Which is 91 over 3. Okay, so a short summary or conclusion. For the u substitutions, the hardest part is to figure out or to realize that we have an inner function and then the outer function. We're going to set the inner function as our u and find the du. You might, depending on the situation, you might have a really nice du that is exactly, you can find the exact combination from the original problem. Or you might need to twist it a little bit, like here. Then when we have a definite integral, like this case here, you do need to pay attention that the -1 and the 0, those two are for the original variable y. When we change to du, we do not have -1 and 0 anymore. We have to change it to the corresponding u value, or you can wait until the end, and you can plug in y in terms of 0 and -1 and solve in that versions. Depending on which way you prefer. Let me see if I can really quickly erase part of the work. Okay, so for example, let me just erase it. Just keep the final answer. For example, I'm going to just ignore this is a definite integral. And then I find my derivative, which is 1 over 4 times 1 over 6 times u to the 6th power, which is u to the 6th power over 24. But I do not want to, or we cannot have u. We have to replace it back as 2y squared minus 3 to the 6th power over 24. Now we can evaluate from -1 and 0. Then 2 times 0 squared minus 3 to the 6th power over 24 minus 2 to the negative 1 squared minus 3 to the 6th power over 24, which is still negative 3 to the 6th power over 24 minus 2 minus 1, negative 1 to the 6th power over 24. And I already did the calculation before since we got the same term. We got 91 over 3 as the final answer. So this is another way to do the definite integral. If the problem is short, you can choose this way, but if the problem is so long, we have a lot to do we have a lot of steps to do for the integrations, then at the end you probably already forgot this is a definite integral. Then it is easier to calculating your u value at the beginning and just evaluate it in terms of u. And that's it for this video. See you in the next one.